Hi there. I wanted to work some more problems with confidence intervals and learn a little bit more about them. We're going to take a deeper dive into understanding confidence intervals and dissect them a bit in this problem. Suppose we asked a random sample of CCBC Essex students whether they plan to vote in the next presidential election. After the data was collected, we reported a 99% confidence interval, which was from 0.548 to 0.662. Let's put a little summary statement to that so it makes more sense. What it's telling us is that we are 99% confident that the proportion of all CCBC Essex students who plan to vote in the next presidential election is between 0.548 and 0.662. Well, if you're uncomfortable with the language proportion, you could insert percent instead. And then we would say it would be between 54.8% and 66.2%. So my question now is, we were just given the upper and lower limits of this confidence interval. What was the sample proportion, p hat? And also, what was the margin of error in this study? So I argue you can find this. It's here in the information they gave us. It's a bit indirect, but we can dig a little bit, use some basic algebra skills, and figure out these two values, p hat and e. So I asked students to visualize this. It's a good way to sort of wrap your mind around this. So here's a number line, and we're going to label our number line with our lower and upper confidence limits. There they are. They're on the number line. And I want you to think about, just for a minute, after having created a few confidence intervals already, where is the point estimate in this interval? Where is p hat traditionally? Well, if you were thinking the middle, you're correct. And here's where I'm going to borrow from like an Algebra 1 class. Back in Algebra 1, we learned the midpoint formula, where we could take two values and find the midpoint between them. So I'm going to take, and again, that will be where p hat is located, the middle. I'm going to take my upper confidence limit and add my lower confidence limit to it, and divide that sum by 2. This is the midpoint formula. And I end up with 0.605. There it is. That is the middle of our interval. So again, if you like percents, our sample value here was 60.5% of students said they would vote in the next presidential election. So here's a formula. It's nice to kind of have one of those for the problems we work. So our point estimate in any confidence interval is the upper confidence limit plus the lower confidence limit divided by 2. Specifically for proportions, it's pretty much the same. I just labeled the left side of this equation with p hat. Now, how about that margin of error? So again, you've probably computed a few of these, some by hand, some with StatCrunch at this point. And we want to, again, visualize what part of this diagram is the margin of error. What does it represent? Well, if you were thinking, again, gave you a little time to think, it's the distance from the center of the interval out to the confidence limits, you would be correct. Here they are. And I say they, plural, because our margin of error means that we move to the right and to the left of our point estimate. So we're going to, again, try to figure out what distance did we go to get from p hat out to, let's say, 0.662. And there's lots of ways mathematically to do this. I'm going to show you a very nifty one, which is if we subtract and take our upper confidence limit, subtract off our lower confidence limit, which gives us the entire width of the interval, and then I just simply divide that by 2, I get 0.057. That is our margin of error. So if you think about it here, kind of got a little animation going on down here to the right of the down in the right part of the screen. If we add that 0.057 to our 0.605, we do indeed end up at 0.662. So mathematically, that is how we find it. Finally, a formula. For any confidence interval, doesn't matter if we're trying to estimate means, proportions, or maybe even a standard deviation. If you want to find the margin of error and you have confidence limits, You can take the upper confidence limit, subtract the lower confidence limit, and divide by 2. I hope this was helpful.